Okay, initially, when I wrote up the syllabus, I'd said the quizzes were going to be at the beginning of class. And that's, standard for what I do in all my classes. But I think you guys are going to take a varying amount of time taking the quiz. Some people are going to get through it in 5 minutes, some 10, some 15, some 20. So I decided what I'm going to do instead is give the quiz at the in-class quiz at the end of class. So I will stop class. We start at 9:30. I'll stop class a little before 10:30 so you could get situated, and then the quiz will start at 10:30. And then for today's quiz, it could go on until 11. So you have 30 minutes. You're not going to need 30 minutes at all. Okay, but you'll have time to just go slow and check your work. And I'm going to stay on the whole time. In fact, I'll stay on until 11:10. Those of you, I know some of you are in Physics 4B, and that ordinarily would start at 11:10, but I checked last night and Marcus is teaching it asynchronous, so there's no Zoom meeting. So does anybody have a class at 11:10?
He is doing labs on Tuesdays at 11:15, and those can be asynchronous, but he's doing them live.
Okay, so he's teaching lab on Tuesday instead of Monday or Wednesday during the regularly scheduled lab time.
Yeah, we're not required to attend live.
But okay, but no, but you should be there. You want to be there live. Okay, great. And that starts at 11:15?
Yes.
Okay, so class gets out at 10:50, and when you had statics lab on Friday, did you get out 10 minutes early or no? You went over, it sounds like.
Yeah, that went over.
Yeah.
Okay, all right, so I still owe you 10 minutes. You'll get the 10 minutes today, probably. And then whatever he missed, Rob told me that he's making up this Friday, which he had time to make up anyway. He had topics he wanted to cover both Fridays, and some of them he'll just cover this Friday. Okay, so at like 20 after 10, I'll let you guys get situated, and then I'll open up the quiz, or 10:25. So we're going to start today's topic then. I went over all the resubmittals that people did for homework 1 and 2, and they're graded. Some of the discussions are graded already. I did not grade the homeworks that you turned in last night at 10, although I was up doing work at statics after. Okay, so we're going to just start on today's topic. I have all your names here, and I'm thinking, I remember the two, is Cody on? No. Laura, you're on. Laura, did I call you on Thursday to answer a question, or not yet?
I'm sorry, what was that?
I said, did I call you on Thursday to answer a question or no?
Yes.
I did get to you. All right, Liam. Is Liam here? I don't see Liam. Okay, so Luis, you're here. Right, is Luis here?
Yeah, I'm here, Julian.
Okay, great. So you're going to be the first one to answer a question, okay? And then we're going to go on from you. And remember, if you want, you could pass. What was that, Luis?
I just woke up, so give me a second.
Okay, so next time wake up earlier. Okay, so does anybody look at the module? I'm gonna go to the module for now.
Cheyenne?
Yes.
I have a quick question about the quiz, like announcements, like where everyone else seems to know about this, is fairly typical. Where are they announced? Like I don't see it on the calendar, I don't see it in modules, I didn't see it like in this week thing, like where?
I announced in the syllabus, it says every Tuesday for the first 15 minutes we have a quiz.
It's straightforward.
So every Tuesday we have a quiz. And then I don't post the quiz, because if I post the quiz, then you guys see the quiz ahead.
Yeah.
So the only thing I could do, I'll show you the screen.
But there are separate online quizzes like the Force and FBD.
Correct. So if you go to,
Separate tab.
just hang on while I move some of this stuff here.
And those are a separate deal.
So in today's module at the bottom, it said in class quiz, but it didn't say anything, Because you guys can't see what I'm circling right now, right?
No, I see that. It says
Well-
component quiz.
So you
Yeah,
could
but
see the,
on a student view, we don't have that.
what? Okay, on the you don't see it because even though you could see it now, I'm
I
showing
see it on your screen. I don't see it on my screen.
right, because it's not published. If I publish it, then you see the quiz ahead. Maybe what I could do,
Yeah.
I have an idea and I'll take care of that offline.
Okay.
But just know every Tuesday we have a quiz.
Oh,
So
deal.
then you could just post the quiz and lock it until Tuesday at 9:30.
Just lock it.
Yeah, you've
Yeah.
done that actually with some other, like with the other quiz that wasn't
Online
available.
quiz.
Yeah.
But could you still see that it's written here? You would still be able to see that
Yeah,
it's there?
it would show up on the module, but
Okay.
you'd click on it and it would say this quiz is locked until, September 8th at 10 and
Okay.
9 a.m. or whatever.
All right, I have a running list of things that I've on Canvas, so, and I've gotten a number of them done already.
For the record, you're doing Canvas better than any of our other, or at least my other instructors. So
Thank you
currently
for
the
telling me
benchmark.
that, Isaac, because I do feel like an idiot. Okay,
No, you're doing great.
okay,
The holy
you're
thing.
the benchmark.
Yeah.
okay, great. All right, well, I'm glad I spent all that time in the summer doing that instead of having fun. Okay, so on modules, this is today, and notice the module for today is today and Thursday, because what we're doing this week, the topics is setting up problems, okay? And what I want to show you first is the steps in solving statics of particles problem. So, Luis, do you remember what the difference is between, I need water. Think about this while I go get water.
Okay.
What is the difference between statics of particles problems and our rigid body statics problems? I'll be right.
Question.
You know, even though that was Luis's question, you could all have had the chatter. You know, I didn't hear any chatter, but you guys.
Oh, I'll
kept talking
chatter.
about it.
Who's got ideas on this?
I'm gonna
Okay,
pass
Louise.
because I can't even think right now.
Okay,
How about? Oh, can I say something? How about? Or is it all given away? No, it's his. It's his. You
I'm
take
going
it.
in order.
Go for it, Louise.
Mackenzie. Is Mackenzie here?
Yeah, I'm
Okay.
here.
You
I'll
are.
pass though. Yeah.
Okay, Marcine. The difference between statics of particles. Okay, Mackenzie, I'm backing up to you. You're gonna answer the question. You ready? Okay, so if we're doing statics, a statics problem, and everything is treated as a particle, a dot, versus statics problem where we're looking at a whole body like a beam or a bracket. Why can we treat a body as just a point? What kind of forces are we looking at only? Or what kind of possible motion are we looking at if everything can be treated as a particle? Are you still
Can I
stumped?
pass yeah, can I pass again?
Okay, Marcine? Just say pass if you want.
Pass.
Okay, Maria?
Is it just because we're looking at linear motion?
Great. Okay, that's good. That's half the question, half the answer. Yeah, now,
Okay.
yeah, we're getting there. If it's only linear motion, what kind of forces are we looking at? When could you treat a full, huge body as just a particle? What kind of,
Hold on.
Say it again.
Um,
Are you looking for the name of that type of
Yes.
statics?
All the forces. Okay,
they're loads?
concurrent forces.
Oh.
When we have concurrent forces, and we talked about this, so it's really important that but you're gonna have a quiz on forces anyway coming up. But we talked about this. When we have all forces coming off at one point, we could treat the body as a point. So all these forces for statics of particles problems are all forces coming off the same point, which means they're all concurrent forces. That's what they're called. Concurrent forces are when point loads are all coming off one point. And as Maria said, if all the forces are coming off one point, we're looking at only the possibility of linear motion. Okay, so let's take a look at the steps.
But also to use other vocab words that we should be playing around with, like
Well,
you can't have.
The other one was when you treat a statics problem, if you treat a body as a rigid body, it means that forces aren't just all coming off another point. There's forces coming off other places. So, and I posted this in the, let's go to read through, you guys, you should read through the module after lecture because I'm posting, shoot, I'm taking the extra time to take a picture and post the lecture notes. So please look at it. You know, okay, so where is our lecture notes from motion discussion? So this is what your notes should show, or again, you don't have to take notes. Instead, what you do is you just listen and then you go and look at my posting. So here we have all concurrent forces where all the forces are coming off one point. And the only type of motion I could have is linear. When we have forces that are coming off different points, like this point, this force right here is not coming off the same point as all the others, this cannot be treated as, these are not concurrent forces. Only these three are concurrent with each other. This produces the possibility of linear motion. This produces the possibility of linear and rotational. And this is called, when you do a statics problem with a dot, it's called statics of particles, where when you're doing statics with a body, it's called rigid body statics. Maria, you had a question.
Yes, I did. I was just going to ask you to repeat what you said, like the definition for concurrent forces is.
Sure. So concurrent forces is when all the forces come up off one point. Your next online quiz is all about force names. But what I suggest to you is, you know, what is the purpose of a teacher, or me in this case, or my philosophy is I take the textbook, or actually I take 10 textbooks when I first taught statics. I take all the textbooks and I come up with what I think is important, and then I decide how to present it in a way that I think makes sense. So whatever I'm presenting to you in lecture is really important, and you should go over your notes or fast speed through the lecture again. But I would have assumed that this you all got already because I already taught it and I didn't hear any questions and nobody came during my office hours. Does everybody understand now? Like when I teach something, I'm assuming you're getting it, although I am quizzing you on it.
I have a question, Joanne.
Yeah, David.
I think maybe I had the misconception that a statics problem would never have any motion, but I think we clarified that there would just never be acceleration. So something that could be moving, but not accelerating. Is that right?
Good question. And let me, so I didn't do a good job in explaining that. Statics is all when we do statics problems, all the bodies are not moving, period. They are not moving. What we are trying to do though is it's important that we do have a motion discussion, and you realize that there are only two different types of motion a problem can have. And in statics, we're preventing both of those motions. So I don't remember who said this the other day, but in terms of linear motion, translational motion, forces that are concurrent can cause linear motion. And non-concurrent forces can cause rotational motion. In statics, we're saying that there is no motion, so all the forces equal 0, meaning there's no linear motion, and all the moments are equal to 0, causing no rotational motion. So in statics, we are only doing problems of non-moving bodies. But we need to understand the two types of motion first, so we can make sure that we're preventing them when we solve when we solve statics problems. But in addition, David, you're correct that we can use statics analysis to solve problems where the acceleration is 0. And you'll see that when you get to dynamics, when things are moving, there may not be acceleration. But in statics, we're not dealing with acceleration. We're not dealing with velocity at all. Nothing is moving. That is our hope. We
Okay,
hope nothing breaks.
That was very helpful. Thank you.
And it's always good, please ask these questions because it's always good for me to explain things a second and third time.
Like ultimately having a resultant at all sort of keys into the study we'll be doing in dynamics.
Right. And
where
what I did
something
mention,
is about to move.
right. What I mentioned at the start of the resultant class was that it's weird that we're solving for resultants that are not 0, because in statics, resultants is 0, right? But the statics teachers and authors want to make sure that you're comfortable finding resultants first. So they're first having you, so the first thing we did in class, the first topic we did was finding components for both 2 and 3D problems. The next thing we did is we solved for resultants, right? And resultants weren't equal 0, so we really were doing dynamics problems then. But I wanted to make sure that you were comfortable solving for resultants. Now we are going on to statics problems. So basically, the components and finding resultants are the foundation on which statics is built. Okay, Jordan, you have your hand up. Would you
Yeah, I
tell-
was just wondering when the resultant can equal 0.
The resultant will always be 0 when there's no motion. Right? So the problems that I gave you in homework 3 and 4, and basically those are only a few problems in all the textbook problems, all those problems, the resultant was not equal to 0, because they wanted to make sure you were able to solve for a resultant and also solve for the direction angles. If the resultant was 0, you wouldn't be solving for resultant angles. The direction angles. But now today, we are doing statics problems, so the resultant is equal to 0. Did that help, Jordan? Jordan?
Yeah, I was nodding. Sorry, that was helpful.
Okay. Yeah, I only see 4 people on my screen while I'm sharing a screen. Okay, so I'm going back to modules now. Okay, so I'm going to close this. And I know you already watched where are we? You guys already watched this video lesson because you already take the first quiz. So these discussions I already had, but it's an extra teaching lesson. And for today's class, I'm just going slowly just to make sure I know where everything is on here. And I was told by the graphics class from last semester that it's important to write the dates of the modules. This way you know what was covered each date. So that's what I'm doing this time. So here you have 2 more video lessons, forces and free body diagrams and force terminology. And then you will have an online quiz too, which is due 10th in a couple of days. So you'll have 2 short video lessons.
So that's for today. Oh, that's that module is labeled today and Thursday.
Right.
So in general, when should we have watched those videos by?
So what I would, I like working off modules, but I remember last semester that students were more comfortable working off the calendar. So click on the calendar and then you see when things are due.
But I don't see those videos.
Right. And you don't see this in-class quiz either because I didn't publish it, and you don't see, but you see this online quiz and it says here, important directions for force online quiz.
We see the videos. I think
Oh,
it
there's
means
your
we
answer.
don't see when should we have watched them by, like before class or after class, or is that accurate?
The directions say
Yeah.
watch these before you take this quiz, right?
Right, see here are the directions. Please watch the following video lesson. Okay, why don't you guys look at how I present this and you let me know next time, or let's do it in a Q&A session. Let me write it down.
Okay, so this would mean the quiz that this is referring to is on September 10th.
Is due.
So
The
the
quiz
answer
is
is
due then.
sometime before we take the
Right.
quiz on
So
September.
I want
10th.
suggestions from you on how I want to list this. And Jordan, you seem to be maybe the expert in Canvas. Okay, so I want to start the lesson because now we're at 9:53, all right? Okay, so you could give me suggestions, but basically you have to watch those 2 videos before you take this quiz.
All right.
Okay, so where I am now is under class notes. And here are the steps to solving this is where I started. We're talking about statics of particles problems, and we're looking at the steps to solve them. And in engineering, we always think about, look at what is given and what you need to find in a problem first. So we're going to start with that. And all this is under setup. What we're doing today and Thursday is setup. Okay? So we're first going to look for the given and find. We're going to set up a table. And we're going to draw a free body diagram. Okay? So the whole setup here is given and find, table, and free body diagram. I'm going to go back now to the modules. And in here is where my open link in a new tab. These are the problems we're going to be looking at. There are 4 problems here. And this is what we're going to be looking at today. And I'm going to now stop sharing. And I'm going to turn on the overhead. So I printed out what the setup is, and I'm going to write it up here. So wait until you see it. Okay, why is it not going on? Come on, baby. All right. Can you read the problem or no?
Not focused.
It's kind of fuzzy, yeah.
Oh,
Good?
better, yeah, good enough.
There we go.
Okay. It doesn't allow, it's not a manual camera where I could turn the automatic focus off. Okay, and let me just move this. And I'm gonna zoom in a little. Everybody good?
Can read it.
Okay, so we're looking at statics of particles. And what does that tell you? It means that we're working with concurrent forces only. And we're only going to try to prevent linear motion because there is no rotational motion possible at all. And we are only this week, we are only doing setup. We are only setting up the problems. What are we doing? Tell me, everyone.
Setting up.
Set up.
We're only setting up the problems. And the setup includes given and find, a table, and the free body diagram. And in these next 2 days, today and Thursday, we're working on 4 problems. Okay, so we're going to do given. I always write sketch info because I'm not going to rewrite what's in the sketch, but certainly the sketch has a lot of given information in it. We see there's a cylinder there. It's resting on a surface that's inclined. We see a cord. We see the cord is connected to the ceiling. It's off a 75 degree from the horizontal. But in addition, we have to read the words. And I know maybe as engineers, we like to look more graphically at stuff and not look at words, but we need to see the words. It says a homogeneous steel cylinder. So why are they telling me it's homogeneous? Mackenzie, do you want to try that one? What do they mean? What's homogeneous mean?
It's like the same.
The same. So all the material in here is evenly distributed. It's homogeneous, which means where is its center of gravity? Mackenzie?
All at the same point.
It's all at the same point and it's in the center. So this cylinder is made of some material. I don't think it tells us what material it is. No, but we'll be learning that it's homogeneous, which
Steel.
means it's the same material. Oh, steel. There it is, steel. It's homogeneous, meaning that it's the same throughout. So that means the weight is all concentrated in the center. Okay, so homogeneous was important to read. It weighs 500 pounds. Does it say that it weighs, does it show that it's 500 pounds in the picture? No. So given, the weight is 500 pounds. It's supported by a flexible cable. Why are they telling us that it's flexible? Marcine, take a guess. What can you do with a cable or a rope? What kind of load can it take?
So it can move around.
Say it again.
So it can move around.
Certainly it can move around, but even if it was a stiff bar, it still can move, right? But what kind of loading can it take? Can it take tension? Can a cable or a rope, a wire rope, take tension? Can I pull on the two ends?
Yeah.
Yes. Can I put compression on a flexible rope? Think about it. If you have a rope in your hand and you take the ends and you try to push the ends together, what will happen to the cable? It'll bend, right? So that means that a rope can't take compression. So the reason that they're telling you that it's flexible is it can only take tension. And I'll put this over here, weight at center. All right. Okay, Maria, you're next. Oh, sorry, I'm going to go over you guys again, but it also says it's a smooth inclined plane. Why are they telling us this inclined plane is smooth?
So that we don't have to think about friction.
Great, no friction. And by the way, we're not going to get to friction until halfway through the course, if probably even 2/3.
internet
So no friction ever
might-
until we
might
start
be
talking about
bad
friction. What was that,
right now.
Maria? Maria? She froze. Okay, determine the tension. So basically they told us it's homogeneous. We don't need to write it down in given, but now we know in our heads that, okay, the weight's at the center. It's flexible. We know it cannot take any kind of compression. But if it was a bar, it could have taken compression. And we're learning that it's a smooth inclined plane, which means there's no friction. I'm not going to write any of that down though. Okay, then find. Determine the tension T in the cable and the force R exerted by the inclined plane on the cylinder. So it is standard in forces that W, capital W, represents weight. Does everybody agree? It is standard that capital T represents tension. Does everybody agree? Okay. Now, they're telling me that there's a force R exerted by the inclined plane on the cylinder. What the hell are they talking about? What is R? What is it?
Normal force.
The normal force. Stupid. Stupid they put R. Put an N. Maybe they were trying to confuse you. But it's a normal. They want you to find the tension and the normal. Let's use standard variables. W for weight, capital T for capital W for weight, capital T for tension, capital N for normal. Okay? All right, so we read all the words, we did the given and find. Great, we've done the given and find. The next thing is we have to draw a table, which I know you haven't done before. So my table is force, magnitude, direction. Okay, is Matthew here? Okay, Myra, you're here, I see. Okay,
I'm here.
Myra. So from the sketch and from the information, what forces are present in this problem? What forces do we already talk about?
From the weight.
There's a weight. What else is there? What other forces?
We need to find tension.
Tension is also in this problem.
And the normal.
And the normal. Miles, do you see any other forces in here that we haven't thought about already? Do you see anything else in here?
No, I don't.
No. Good. So these are the only forces present. So now in this table, we're either going to use a check mark or a question mark. A check mark means we know it, and the question means we don't know it. So we're up to Peter. Is Peter here? Yeah, Peter.
Yes.
Peter, do we know the weight?
Yes, 500
Yeah,
pounds.
they told us it's 500 pounds, right? We know it, check mark. Do we know the direction of weight?
Yes, in the direction of gravity, so facing down.
Weight always goes down, so we know the direction. Weight always goes down, always. Okay, Tim, how about for tension? Do we know the magnitude of the tension?
We do not.
We do not, so we have a question mark. But do we know the direction of the tension?
Yes.
Yes, tension always goes along the line of action of the wire or the rope, and it goes away from the body we're analyzing. Tim, what body do you think we're going to analyze?
As we're analyzing the steel cylinder.
Right, we're going to analyze the steel cylinder. So if the tension always goes away from the body we're going to analyze, the tension is going to be like that. And I'm going to write here scrap, because I always write on my drawing scrap. Okay, and we're going to talk, I'm going to talk more about this in that video on forces. So we know the direction. I'm up to Tony. Is Tony here?
Yeah.
Okay.
Yeah, I'm here.
Tony, The normal, do we know the magnitude of the normal?
It would just be it'd be
Actually,
the weight.
let me change my question. My question is the normal given?
Okay, no.
No. Because what you were going to do is you were going to do static analysis to find it. Okay,
Okay.
how about the direction of normal? Do we know the direction of normal, Tony?
It would be opposing the weight of the force of the cylinder on the surface that it's lying on.
Okay, so what I'm going to tell you here, which is also in the force video, is I'm going to zoom in right now.
A little too close.
Zoomed in, all right.
Yeah, definitely too close. Hang on. Bear with me. Great. And again, this is in the video. I'm going to erase this right here, and I'm going to erase this too.
What is the degrees on the tension?
75. We'll talk about that in a minute. I'm not drawing, I didn't draw the free body diagram yet. That's the third step. Okay, everybody look at this picture. Everybody with me? Okay, we always know weight goes down. Definitely.
Yeah.
Okay, in here, there is some contact between the surface and the cylinder.
Mm-hmm.
The surface is loading, is pushing on the cylinder with a normal force. And the cylinder is pushing back with the normal force, a compression force on the surface. So when these two things are touching, the cylinder and the surface, there is a normal coming from the surface to the cylinder, and there's a normal from the cylinder to the surface. And this is the third law of Newton, right? Third Newton's law, equal and opposite. There is a normal here, and there's a normal here.
So perpendicular to the surface.
And they're perpendicular to the surface. And I'm not going to talk about the angle right now. I'm just going to say it's perpendicular to the surface. So right now, everybody's listening, right? This is really, really important. Right now, these two things are touching. They're touching. You can't show my hands. If you put your hands together, push your hands together. Your left hand's pushing on your right hand with a normal. It's a compression force. Your right hand is pushing on the left hand with a compression. Okay? Once you pull one hand off, that body, and you're going to do this, you might have done this last Friday or this coming Friday, but when they're touching together, the forces are internal to the system. One hand's pushing on the other hand, the other hand's pushing on the other hand. It's internal. It's not until you separate the body, which I'll separate the body now. You can see the body. Now I'm only analyzing the body, and there's a normal coming at it. This is the same. I'm going to use green now. This is the same for the tension. Right now, there is a tension. There is a tension there's a tension here that's pulling the cylinder, but there's an equal and opposite tension up here. And when this cable is intact, the tensions are internal and they're balancing each other out. Just like here with the normals, when the surface and the cylinder are touching each other, there's an internal force here, internal force. It's important to realize that Because if I wanted you to analyze the ceiling, you would be able to determine what loading the tension is up here and what's going on up here with the ceiling. Okay, so I'm going to zoom back out. I'm going to you're reading my paper correctly, right? Because I'm seeing it backwards.
It looks
No,
good.
It's
correct.
good.
It's good. All right. Okay, so let's get back to the normal table. So I think I'm going to guess we're still on Tony. So Tony, you said there's a normal force. Do we know the magnitude? No, but do we know the direction?
Yeah.
Yes, we know the direction. So in the end, since we know this table has all the forces, how many unknowns? So Victoria, you here?
Yes.
Okay, how many unknowns are there?
There's 2 unknowns.
2 unknowns. In order to solve for 2 unknowns, how many equations do I need?
Thanks.
2 equations?
2 equations, yeah. You have to have the same number of equations as unknowns. And if we need 2 equations, can we analyze? We only need one body because we could get the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0 from one 2-dimensional body. So we only need to analyze one body. The reason I set up this table is because there will be times the force is known, but the direction is unknown. We're dealing with vectors. The weight carries 2 pieces of material. It's the magnitude of the weight and the direction. And the tension and the normal also carry 2 pieces of material, the magnitude and the direction. So it's important to realize that really we have 6 things we're looking for. We have 3 forces, but we need to know six things. And out of those 6 things, we know 4 already. There are only 2 things we don't know, which is the magnitude of the tension and the magnitude of the normal. And if we have 2 unknowns, we need 2 equations. And for one body, we could find 2 equations. So we only need to analyze one body. Going back up to the beginning of the problem, the setup included the given and find we did, the table, which we just did, and now we're left with doing a free body diagram. And I'm going to go back over here. Remember, this drawing was all scrap. I'm writing on the diagram that's given. Now I'm going to draw a free body diagram. So now, we're back up to Adam. Adam, what body do you want to analyze?
Cylinder.
Right. Can I reduce the cylinder to a dot, to a particle? Yes. Why can I reduce it to a particle?
Because it's homogeneous and all the forces are concurrent to the center.
Correct. 1, it's homogeneous. And 2, more importantly, all these forces are concurrent. So I'm going to draw my weight going down. I'm going to draw my normal going here. And I'm going to draw my tension. Okay. What is missing from my free body diagram? What's missing? So I'm on E. What did I forget to put on the free body diagram?
Your angles?
Great, angles. I have not shown any directions on this free body diagram. I did show my variables, because these are variables, and this is 500 pounds, so I'm going to put this on there so I don't forget and think that the W is an unknown. So forces all have to be labeled. They have to either have a value or a variable. So I'm going to actually erase the W just because I don't want to confuse myself. I don't want to think for one moment I don't know it. If I want, I could put the W over here. So what is unknown is my T and my N. So I actually included on my free body diagram my what I'm representing my forces at, but Amani said I didn't show direction. So you guys, take a look at this now. I'm going to zoom in on this. All right, and I think I might have, I showed it in one of the videos. Take a look at this. Here is 55 degrees. Does everybody see the 55? Do I have to zoom in more? You're okay. Thumbs up, okay? Okay, 55 degrees is between the surface and the x-axis. In geometry, you learned so long ago that if you have two forces, if you have two forces and you know the angle between those forces, and then you have two other forces that are perpendicular to those, the two angles are the same. So that means this angle of 55 is the same as the angle this pink direction is perpendicular to the surface, right?
Yes.
And this line right here is perpendicular to this horizontal. So because 55 lies between the surface and the horizontal, this angle is 55 because this line is perpendicular to this and the vertical line is perpendicular to this. So this is where the 55 degrees is. It's between the force and the y-axis.
Question about drawing.
Yeah.
So,
Isaac?
is it acceptable right from the beginning to move the normal force so that the tail is at the particle, like right away?
Yep, you can put the normal up here if you want. I tend to do it this way to begin with because I want to show that it is a compression force. It's not a tension force. It's being pushed towards the body. But yeah, you could just draw it up here. No problem at all. Okay, what about the tension? In this drawing here, it's showing you that this right here is 75 degrees, right? So this line and the x-axis are parallel, which means if this is 75, this is 75. So that means right here is 75 degrees.
Nice.
And remember, this is our free body diagram we're drawing. This is scrap. Okay, so now what else? Angel, what else is missing? It's a free body diagram. I now have shown the force magnitudes and I've shown the force directions. What's missing? Angel.
Are we missing Newton's second law analysis on the free body diagram?
And which one's the second law?
That's the sum of forces.
No, we do that in equations later on. We don't show it on the free body diagram. The free body diagram is not about math. It's all about graphical representation.
Damn, I got excited.
Oh, sorry. Vaughn, what's missing?
I don't know. I was going
How
to
do
say
you know
what
whether
Angel
these
said.
forces are positive or negative? What do I need to draw?
Axes?
Well, we already have
Yes,
the
axes.
direction.
I have to draw my
Oh.
positive axes.
Yeah, that's right. That
This
makes sense.
is a damn good, not no damn good, a damn good free body diagram. It shows the forces with either its magnitude or its variables. It shows the direction of those forces and it shows the axes. This is the free body diagram. From now on, FBD, free body diagram. How's everybody feel?
Okay.
Okay, I'm gonna stop. Does anybody have a question? You want me to go over something? So what we did, the setup included given and find, the table, and the free body diagram. We wrote given, we wrote the sketch info. That's all we wrote, sketch info, because we want somebody to look at this. We read all the words and we found any the thing that's not in the, that's in the words, it's not in the picture, was the weight. So we wrote weight is equal to 500 pounds. Then we wrote the find, and in the problem, it asked us to find the tension in the normal. We set up a table showing what, for each force, do we know the magnitude? Do we know the direction? We found that there are two unknowns, which means we need two equations, which means we need one body. We chose the body. We noticed these are all concurrent forces, so we could reduce it to a particle. We drew all the forces with the directions on it with the axes. So now I'm going to stop sharing this. Do you want me to post these notes on the module? Okay,
Yes.
if I do that, you're telling me that you're going to read it.
Mhm.
Because it's a lot of time to take a picture, save it to the fucking network, then save it to the fucking canvas, and then upload it. And remember to upload it in
my.
a certain way. All right? And imagine how much that takes away from me doing statics problems. Okay? So if I'm going to do that, people are gonna need to look at it. Okay? And again, I don't mind if you don't take notes, you have the notes. Okay, I'm gonna stop using this thing now. Okay. So we're gonna get ready for our quiz soon. So this is set up, and today and Thursday, that's all we're doing is setting up problems. We set up one today, and we're gonna set up 3 on Thursday. Okay, so now I am going to share my screen to the module. And so let's look at the module. Here are the steps we're following, but we only did the setup because that's all we're looking at is setup. Here are the 4 problems. If you want to go ahead and look at the other 3 problems we're going to do on Thursday, you can. Here are 2 new video lessons, which are talking about forces, which is what I'm talking about today. Here you have the 2D setup problem, which is due September 10th. And there will be a 3D setup problem, but we haven't done a 3D yet, so I haven't assigned it. Notice there's no due date. There's an online quiz that's due on the 10th, and then we're going to take the component quiz now. So everybody needs to clear their work area. You're allowed a 3x5 index card cheat sheet. Some of you may have made it, maybe you didn't, but make sure you make it for the next time. It's a good way to study. So you have that cheat sheet. And you're going to need paper. Hopefully all of you have engineering paper or are getting engineering paper, so you need paper. And I need to move your faces. So what I'm doing now is I'm publishing it. I'm not going to publish the solutions, but I'll publish the quiz. Okay, and now let's take a look at the quiz. You're seeing my sharing. So open in a new link. And let's get this puppy bigger. And that doesn't look good for me. Let's see what I could do. Okay, this isn't looking good. Okay, I'm gonna go to the file. I think it's too small.
Joanne, are we going to submit our scanned piece of paper, or is it something we do electronically to submit it?
You're gonna submit it, so I have to figure that out while you're taking the quiz.
Okay, thanks.
So you're gonna have to submit it like you submit homework. 2D component quiz. Publish. Let's open it up. Remember, This quiz is on components, what you learned last week. It's not on what we're doing right now. I'm not testing you on setup. I'm testing you on components. And I shouldn't use the word test. I'm assessing on whether you know components now. Why is it taking so long? So remember, quizzes you have to take on your own. This is the only way I can assess whether you're getting this stuff or not, right? This is the way I know that I need to give you extra time outside of class on something. Why is it taking so long? Okay, I'm gonna stop it and I'm gonna just go in myself. All right, I'm going over somewhere else. Okay, I'm going back in. I'm sharing the screen. Okay, could everybody see that? So you see the schematic here, right? Do not draw a free body diagram. Do not draw the diagram, okay? Because it'll just take time. I want to make sure that you're comfortable with the math. So it says, find the components of the 800-pound force in the sketch to the right using the 3-step process and performing 3 checks. Be sure to show your units. So what I want you to do is using the 3-step process, I want you to find the components of the 800-pound force and represent it in vector form, magnitude and unit vector, and magnitude and direction angle. All right? And here is the point spread. Okay, so I'm good. We're ready 2 minutes before 10:30. So you have until 11. And I'll be here. I think.
Joanne, did you manage to put this on Canvas, or are we just going to do it off of your screen? I'm not seeing it on the Canvas page.
I found it on Canvas.
Oh,
Yeah,
okay.
it's in the modules. You're also muted right now, Joanne.
Thank you. No, it's there, and just refresh. It might be that it's not published, but it's published.
We are assuming these are concurrent.
We just have to do one. We're just talking about the 800.
Oh, is that right? Express the 800-pound force. Nice. Thanks, Dave.
Yeah, I was gonna do both too.
See, that's why I spend so much time making you read the problems. Because I know we jump